going to talk about vectors today. So remember what vectors are first of all. Okay, they're quantities with magnitude and direction. Okay, so the size of the vector is important. That's the magnitude. For example, a force of 12 newtons, so 12 is the magnitude, and the direction is important. Okay, so remember, if you're hanging off the edge of a cliff and you say help me, apply a force to me, and somebody comes running up to you and pushes you over the cliff, it's your fault. Okay, you didn't tell them the direction to apply the force. So magnitude and direction. And the way we represent vectors is with arrows. So the length of the arrow gives you an indication of the magnitude, the size of the vector, and we give that the letter R sometimes. Okay, and the direction tells you in what direction the vector is going. All right, so that's it. That's what's involved. And if we add, okay, so the first thing we have to do is add vectors, and we have what's called the triangle rule, which is very straightforward. And I'm going to take what's called the displacement vector as the prototype vector, the vector that kind of explains everything. I think everything else follows from there. So if we look at the idea, if you decide you're going to walk 3 meters west, okay, so we would indicate that by 3 meters west, and then 4 meters north. So we'd indicate that by 4 meters north. Now it would be pretty obvious to you that to find out what displacement you are now from your rest position is you would say, okay, you would draw it as 3 meters west, or sorry, I've gone 3 meters east, so we'll say 3 meters east since I want to redraw it. So I've gone 3 meters east and 4 meters north, and clearly when I'm finished going 3 meters east, I start going 4 meters north. That's the crucial point. That's it. That's the triangle law. You put the end of the first vector and the start of the second vector together, and at the end you complete the triangle. That's why it's called the triangle rule. You complete the triangle and there you go, done. Okay, so you added your two vectors and you've got your resultant. Now your resultant is R, okay, and the angle is theta. You always show those in the diagram, and then you have to be able to find R and theta. You should be able to do any of these questions using right angle triangles. That's from the basics from the syllabus. Okay, we'll see later how we can manage it outside the syllabus anyhow. So we use right angle triangles. So in that case, to get the magnitude, so R of the vector, we just use Pythagoras' theorem always. Okay, so in this case, R squared equals 4 squared plus 3 squared. So Pythagoras' theorem, the square of the hypotenuse equals the sum of the squares on the other two sides, and we end up with R equals the square root of 25, and R is equal to 5, in this case meters. And to get the direction, we always use SOHCAHTOA and we always use tan. Well, we can use any of them because we've now got the hypotenuse, but normally since we've already been given the opposite and the adjacent, we use tan. So tan of the angle is opposite over adjacent. Always write that in and then fill it in. Okay, don't fall into the trap of not writing in formula. Okay, and remember, if you have the tan of the angle and you want to get the, what's called the arctan or the inverse tan, second function, okay, so the second function there, okay, so second function of tan of 4 over 3, okay, get an error, so second function of tan, okay, and I get an answer here, 53.13 degrees. Now, if you like, you can call that, okay, it's east 53.13 degrees north to give the direction, the exact direction. But if you have the diagram drawn, you've done that by showing it on the diagram, so you're sorted. That's how you add vectors. That's it. That's it. The triangle rule. There's an equivalent rule called the parallelogram rule, which is the same thing. We'll have looked at in another clip that I'll put up tomorrow because there's an experiment associated with that. But it's the same thing, as we'll see. Okay. So that's step one. Step two is, okay, resolving a vector into two components. Okay, so we take a vector. So let's say we have this vector and we want to resolve it into two components. Now resolving two components means doing the opposite of the triangle rule. Okay, we're turning one vector into two perpendicular vectors. Normally a horizontal vector, a horizontal and a vertical vector, but not necessarily. Okay, there will be situations where that wouldn't be the case, but for the time being we'll worry about horizontal and vertical. So let's say this is a force, it's a force actually this time of 8 newtons, Okay, and the angle is at 25 degrees, or 20 degrees, it's worked out 20 degrees there. Okay, right, so what you do is complete the triangle. So you want this, and you want this. You're effectively doing the absolute opposite. Okay, this is the right angle here. Okay, now you can use Sokotoa, okay, and we can go through Sokotoa, and by using Sokotoa you will see, it's just using Sokotoa, you will see that this side here is always the magnitude times the cosine of the angle, and it's easy to remember. Cosine is adjacent, you know that, so the angle, so the component adjacent to the angle is cosine. The component opposite is sine. And that's it. Okay, so we work those out. So 8 cosine 20 is 7.52 newtons, and 8 sine 20 is 2.74 newtons. So a force of 7.5 newtons, 2 newtons to the right, and a force of 2.74 newtons up will give you, is the equivalent of a force of 8 newtons at an angle of 20 degrees in that direction. That's how you resolve 2